In 2006, NASA launched the New Horizons probe to explore Pluto, the ninth planet of the solar system at the time. After a 9-year journey, New Horizons reached Pluto, becoming the first spacecraft to visit this distant world. Today, the probe has surpassed the 50 astronomical unit mark from Earth, which equates to more than 7.5 billion kilometers. Data from the flyby is still under analysis by astronomers, with new studies suggesting that Pluto is active and not as tranquil as previously thought. But how did astronomers arrive at this conclusion? What unusual observations did they make from the images sent by New Horizons? And most importantly, could this discovery hint at the possible existence of life on Pluto? Hello, and welcome to Z. Please don't forget to subscribe and hit the bell icon. Pluto is a frozen world with a core of nitrogen and carbon monoxide ices. It was the first object discovered in the Kuiper Belt and remains the largest known body in that region. However, starting in the 1990s, the discovery of several similarly sized objects in the Kuiper Belt led to questions about Pluto's status as a planet. In 2006, the International Astronomical Union reclassified Pluto as a dwarf planet, though this didn't diminish its significance as a target for exploration. Images from New Horizons revealed astonishing and unexpected features not seen on any other planet in the solar system. The surface of Pluto shows numerous bumpy volcanoes of varying heights, and unlike the rest of the planet, there are no nearby impact craters from asteroids or meteors. Furthermore, there is no evidence of plate tectonic activity, which is crucial for mountain formation on Earth. These observations suggest that this surface was shaped by geological activity, likely a volcanic eruption within the last 2 billion years, which is relatively recent in cosmic terms. Two prominent peaks on Pluto have puzzled scientists. Right Mons, a mountainous feature, is about 150 kilometers wide, rises nearly 5 kilometers above the surface, and has a central depression almost 50 kilometers across. Picard Mons, another peak, stands nearly 7 kilometers tall and spans about 225 kilometers. Despite Pluto's diameter being only 1/6 that of Earth, the total volume of these volcanoes is comparable to Hawaii's Mauna Loa, one of the largest volcanoes on Earth. These massive surface features are located at the southwest edge of the Sputnik Planitia ice sheet, which appears as the lighter region to the left of Pluto's heart-shaped feature. They were first observed when New Horizons flew past Pluto in July 2015. This ice sheet is characterized by an ancient impact basin nearly 1,000 kilometers wide, with folds and rises resembling wrinkles over a smooth ice surface. Several volcanic domes in this area often merge into larger domes. After analyzing the New Horizons images, researchers speculate that the terrain's formation was driven by multiple eruption sites near each other, with cryovolcanic eruptions covering the region in layers of ice. Detailed studies show that this region's surface material is mainly water ice, not nitrogen or methane ice, which is common in younger parts of Pluto's surface, further supporting the idea of cryovolcanic activity. However, for volcanoes to be active, a continuous heat source is necessary. On Earth, this heat primarily comes from radioactive decay within the planet's interior. Alternatively, heat can result from gravitational interactions with massive neighboring objects, which drive Io's volcanism. But in Pluto's case, neither its neighbors generate enough gravitational force, nor does its core contain enough rocky material for significant radioactive heat generation. Pluto's average surface temperature is around -240 degrees Celsius, with a hard, icy surface that cannot easily melt far from the sun and lacks other heat sources. So, where does this heat come from? The most plausible scenario is that Pluto retains heat from its formation, likely in a deep water ocean beneath its icy crust. Other icy bodies in the solar system, such as Saturn's moon Enceladus and Jupiter's moon Europa, also contain such oceans. Enceladus has even shown evidence of regular cryovolcanism by ejecting icy material into space and replenishing one of Saturn's rings. Nonetheless, the extensive icy volcanoes on Pluto, recycling its surface ice, have not been observed elsewhere in the solar system. However, New Horizons only conducted a brief flyby, observing the region for just one day. Thus, it remains uncertain whether cryovolcanism is still active on Pluto or if the ice volcanoes are dormant. If active, this would enhance the possibility of a liquid ocean and potentially life on Pluto. If you enjoyed this video, please like it and subscribe to our channel for more episodes of the Sunday Discovery series. The New Horizons mission, launched by NASA in 2006, has provided humanity with the most detailed images of Pluto ever captured. When the spacecraft conducted its flyby in July 2015, it revealed a wealth of information about this distant and enigmatic dwarf planet. The images sent back to Earth were nothing short of breathtaking, and they have since sparked a great deal of scientific curiosity and speculation. Among the most intriguing discoveries were unusual features on Pluto's surface and in its atmosphere, suggesting that there is something extraordinary happening on this icy world. The heart of Pluto, Sputnik Planitia. One of the most captivating features observed on Pluto is the vast heart-shaped region known as Tombaugh Regio. Within this region lies Sputnik Planitia, a large ice-covered basin that has baffled scientists. This area is primarily composed of nitrogen ice, with traces of methane and carbon monoxide, and it exhibits a unique cellular pattern. These cells are thought to be caused by convection, where the nitrogen ice is warmed slightly from below and rises before cooling and sinking again. This process indicates that Pluto is geologically active, a surprising discovery for a body so far from the Sun and once thought to be inert. Mysterious mountains and floating hills. Another unusual aspect of Pluto's geography is its mountains, some of which are as tall as the Rockies. These mountains are likely composed of water ice, which is rigid and supports such towering structures in the frigid temperatures of Pluto. Additionally, scientists have observed what appear to be floating hills within Sputnik Planitia. These hills, believed to be composed of water ice, seem to be moving through the nitrogen ice like icebergs in Earth's oceans. This dynamic environment suggests that Pluto's surface is constantly changing, driven by forces yet to be fully understood. Atmospheric anomalies. Pluto's atmosphere, though thin, has also presented some unexpected findings. The New Horizons mission discovered layers of haze extending up to 200 kilometers above the surface. This haze is thought to be composed of complex hydrocarbons formed when sunlight interacts with methane in Pluto's atmosphere. Moreover, the atmosphere undergoes significant seasonal changes. As Pluto moves along its elliptical orbit, parts of its surface can warm enough to sublimate the ice, temporarily thickening the atmosphere. These findings indicate that Pluto's atmosphere is far more complex and dynamic than previously imagined. Possible cryovolcanism. Adding to the intrigue are the signs of possible cryovolcanism, or ice volcanoes on Pluto's surface. The presence of large, dome-like structures with depressions at their summits suggests that at some point, a mixture of water, ammonia, or other substances may have erupted from beneath the surface. If confirmed, this would provide evidence that there are subsurface reservoirs of liquid, kept from freezing by internal heat or the presence of antifreeze-like chemicals. This discovery could have significant implications for our understanding of geologic processes on icy bodies throughout the solar system. The significance of these discoveries. The images and data from New Horizons have fundamentally changed our perception of Pluto. Once considered an inert, frozen rock, Pluto is now recognized as a complex and dynamic world with a variety of active geological and atmospheric processes. These discoveries challenge our understanding of how such distant and cold bodies can exhibit such activity and raise questions about what other surprises may be found on other Kuiper Belt objects or similar distant worlds. In conclusion, the stunning images of Pluto sent back by the New Horizons mission have unveiled a world far more intriguing and active than anyone anticipated. From its heart-shaped plains and towering mountains to its dynamic atmosphere and potential cryovolcanism, Pluto continues to captivate scientists and the public alike. These findings not only deepen our understanding of Pluto itself, but also provide valuable insights into the broader workings of our solar system. As we continue to explore the outer reaches of our cosmic neighborhood, who knows what other wonders await discovery? Thank you for watching and see you next time.